Hello guys, welcome back to another video. In this video, I'll show you guys how to recreate Squid Game, red light, green light inside of Unreal Engine 5. How it works is you spawn in as the third person character at the starting line, and when the doll turns its head away, it means green light and the players are free to run towards the finish line. However, when the doll faces the players, that means that it is red light, so the players must stop moving, otherwise they will be eliminated. This is a very simple game to create inside of Unreal Engine, and everything that you see here is actually set up for multiplayer, so everything is multiplayer replicated. And so I will show you how to set that all up in this tutorial. And if you guys end up enjoying this free tutorial and want to learn more about multiplayer games, I highly recommend you check out my multiplayer survival game course, as it covers more in-depth multiplayer mechanics, things like how to join and host sessions, dedicated servers, Steam sessions, player chat, voice chat, player name tags, saving and loading player data, and it will teach you multiplayer replication basics and all sorts of different multiplayer mechanics like replicated inventory systems, all that stuff that you can't fit into a short 20-minute YouTube video tutorial. So definitely check out the course link in the description below if you want to learn more about multiplayer games inside of Unreal Engine. And with all of that out of the way, let's get right into the video. So for this tutorial, I'll be using Unreal Engine 5.5, create a new third-person character. You can name it whatever you'd like, click create. Now that we're in our project here, we have a simple third-person template. We're going to create a new level, so go to File, New Level, create a basic level. This will give us a blank empty level with a simple floor to start with. Let's create a new folder in our content browser and just name this to levels. And then we can do a file, save current level as, and save this into our levels folder and just rename this to our red light, green light map. Now in here, we're just going to scale up the floor, and we can scale this sort of like this rectangular shape. Okay, and this is how big the game board is going to be, so something rough like that. Then you can just take this and rotate this 90 degrees and scale this down, and this will be sort of like the wall. Okay, so something like this, and we can just alt drag this to duplicate, and these are the basic walls, so we can rotate this 90 degrees and move this like so, and duplicate that again like this. And this is our simple arena. So if I hit play, this is our player start. If you want to see where your player start is, you can search for player start and make sure that the player start is placed somewhere inside of the arena. So when we hit play, this is what it will look like. This is what the arena looks like. Let's go ahead and add some simple textures to the walls and add in some different meshes. So go ahead and head over to the description, where you should have the project files. Basically, these are just some models that I got off Sketchfab, and of course this stock photo that I downloaded. You're free to use whatever you'd like, but this will all work for this demonstration purpose. So in our content, we can create a new folder for our materials, and let's drag and drop these two textures. So this stock photo is like the background. We can create a new material. Just open that up and drag in the photo into the base color, and I'm going to scale this down. So right click on the material node graph and search for the texture coordinate node, drag that into the UV, and we can scale this down to 0.1 by 0.1 for the tiling, and that will actually scale up the material. So let's take our material and drag it onto the background, and this is what it will look like. So we'll just drag it on all the different sides, and yeah, this is what it will look like. Let me go ahead and actually take the walls and move it down just a bit, so that looks good to me. Now for this red line, this is sort of like the finish line, so we'll create a new material. This will be our m_finish line decal, and we can open that up, and we just drag in the red line. You want to select this material node and change this from surface to deferred decal, and the blend mode from opaque to translucent. Then take the RGB, plug that in the base color, take the alpha and plug that into the opacity, and that will give us this red line decal. So save that, and now we can take the red line and drag it into here. We can scale it up, rotate it, and scale it like so. And this will represent our starting and finish line. So let's go ahead and position it where we want. So we have one at the starting line and one at the finish line. Now for the doll and tree model, we can create a new folder for our meshes, and then make one for our doll. Then in the project files, you have the Squid Game doll. So this is just a simple model I got off of Sketchfab. You'll take this model right here in the source, drag and drop it. For this one, I combined the meshes. So I click this combine static meshes when I import, and that will combine it. Then we have the material color.png. You can just drag it and drop it in here. And I'm going to delete the material and create a new material. Just name this to m_doll and double click, open that up. Just drag in the material color and plug the RGB into the base color. Save that. Open up the static mesh, drag in the material into the material slot, and there we have it assigned, and that should be all set up. So we can save that. If we drag in the doll, we need to obviously scale it up and rotate it. Okay, so something like that, and it will be behind the finish line. So let's go ahead and make sure that it's spaced out like that. Okay, you can position it in the center. Now for our tree model, let's make a new folder in our meshes called tree. And in the project files, just go to the tree, source, tree, and take the tree.fbx and drag and drop it. This one, I would change the import settings to import this as a static mesh. So force all mesh type as static mesh and click import. That will just make sure that this tree is imported as a static mesh. Just drag and drop it. And let's scale this up and move this back. It'll just be positioned like this. And if you guys want to rotate and I might move things around, but the basic position can be something like this. If you want to change the lighting, you can do Control L, and that will change the lighting in the scene. So I think I like the lighting to be sort of on the side like this. And I think that's perfect. So just save that. Now let's go ahead and actually set up the gameplay and all the game modes, all the logic for the players. So over here, if we search for our player start, we'll find it over on this location. And if we hit play, we're facing the right direction. So make sure that the player start capsule right over here is rotated. The arrow, the blue arrow, is facing the direction of where you want the player to spawn. So you can rotate it by, rotating it by pressing E. You can also duplicate it by dragging Alt, and that will add multiple player starts, just like that. And to play this in multiplayer, you want to hit the 3 drop-down button and change the number of players from 1 to 2. And then you want to change the net mode to either listen server for a listen server or client for dedicated server. So either one of these will work. Well, I'm going to play as clients, 2 clients. And then you can do play in new editor window. That will pop open 2 editor windows. So this is what it'll look like. You can see that the players spawn at the different spawn locations. And this is basically what the arena will look like. Okay. Now when we exit, we get this error message. We actually get 3 of these different messages. This one is actually a warning. We don't have to worry about this. So you can ignore that. These 2 errors have to do with our player controller. So let's go ahead and fix that. Let's go into our content folder, create a new folder for blueprints. And then in here, let's right click and create first a blueprint class of the type player controller and name this to player controller PC_player controller. Then just double click, open this up and head over to the event graph. Off of the event begin play, we're going to right click, get enhanced input local player subsystem. You want to do a is valid check. And if it is valid, we want to add input mapping context. And for the input mapping context, this is our input mapping context default. Basically what this is doing is it's registering with the game our input controls like our movement and camera controls. Now we just need to assign this player controller in the game mode. So you want to go to your window, world settings. In the world settings, we want to select under the game mode override our third person character game mode. Expand this selected game mode, and in the player controller class, we want to assign that PC player controller. Another thing that we need to do is go to our content, third person, blueprints, open up our third person character blueprint, because in here we have this add input mapping. This is where the error is coming from. So we can actually just delete this because in our player controller, we're basically doing the same exact thing. That's what we set up. So now that we've deleted that and we've added in the player controller, we've assigned the player controller in the game mode. If we hit play here, we're not going to get an error message when we exit. Okay, we get this warning message, not enough login credentials to launch all play and editor instances. This is just a warning. You don't have to worry about this message. So now let's go ahead and set up the doll logic. So in our content blueprints folder, let's create a new blueprint class of the type actor. Name this to BP_doll and double click open that up. In here, we're going to add under the components a static mesh component and select the static mesh. We want to have it be that doll model. For the scale, I'm going to scale this up to 7.25 on the X, Y, and Z. So it's scaled up. And then we want to go to the class defaults. So click on class defaults. And under the details, you want to check the replicates. Okay, so if you're going to make a multiplayer game, you're going to need to replicate any actor that you want to be replicated, or you want other players to see any updates or movement or whatever. You want to check the replicates. Very important. Otherwise, no other players are going to see any changes to this actor. Then you want to head over to the event graph, because this is where we'll set up the logic. So we can delete the event overlap and event tick. We don't need that, but we'll use the event begin play. So when the game starts, we're going to do a switch as authority. This will just make sure that everything that runs after this will run on the server and the server only. So on the server, we want to do a delay. We're just going to wait for about 3 seconds for the duration before we start the game. Then down here, what we're going to add is a timeline. So let's search for the timeline node, add timeline, and this will be our turn doll timeline. So basically we need to rotate the doll, either facing the tree or facing the players. So we're going to do that through a timeline. So double click the timeline, and in here we're going to add a new float track. We're going to right click anywhere on the graph and add a key. Select that key. In here we can set a time and value. So for time 0, we're going to set 0, and value, we're going to set that to 0. Then right click anywhere else on the graph, add another key, select that, and set the time to 1 second and the value to 180 degrees. Now we'll click the zoom fit horizontal and vertical, and we should see both of those points on the graph. So just drag and select both of those, right click and set that to auto, and then set the length of the timeline to 1 second. That way it will end right on that value. Compile and save that and close out of the timeline, and now we have our float value that it's outputting. So in here, what we want to do is create a new variable under the variables and call this red or green light, question mark, to keep track of whether or not it is a red light or a green light. Take this Boolean value and set it, and we want to plug this in for the play from start. So we'll set it to red light, that will play from start. Copy and paste this and plug it in for the reverse from N, and hit that to check to mean red light. So actually this is green light, false is green light, true is red light. So we want to right click and add a custom event over here. This will be called start green light, and set this to run on server. And this will go ahead and set this Boolean to false, aka green light. Then over here we want to add a custom event, call this start red light, and set that to a run on server. And that will set this to true, aka it's a red light. So now we need to update the rotation of the doll. So we need to go ahead and actually we're going to add a multicast event, because we need to make sure that this happens on all of the players who are connected. So I want to right click, add a custom event, and you need to call this multicast rotation, or you can call it whatever you'd like, but this just needs to be set to a multicast event. That way it will run on all clients. Then we're going to pass in the rotation. So we want to get our static mesh, this is the mesh that we want to rotate, and we want to do a set world rotation. So call the set world rotation node, and we're going to pass the rotation value. So take the new rotation, add it as an input, and then over here on the update for our timeline, we can call that multicast rotation event. And now we have that input or the value we can modify. So we'll take the float value and we're going to actually break or make a rotator. So make rotator, and we'll plug in the float value into the Z. That will rotate this doll on the Z axis, so it'll be facing like so. So that will go ahead and execute on all the clients. Now we just need to call this off the completed. So off the completed, we want to call our start green light. So call the start green light event. So now when the game starts, basically, we'll wait 3 seconds. We'll start the green light. The doll will turn around. We'll update the rotation. When that's finished, off of this finished, we need to go ahead and turn back around. So what we'll do is off the finish, we'll do a branch. And we'll check and see if it is red or green. So get our Boolean, check and see if it's a red or green light. Okay, if it is a red light, that means that we need to go ahead and check and see if there's any players who are moving. So the way that we're going to do that is through a timer, because every second or so, we need to be checking to see if any players are moving. And then if so, we need to eliminate them. So off of the true, what we'll do is a set timer by event, so that we can have sort of this ticking event. And for the event, we can add a custom event, and now add a delegate there. This custom event will be called check for moving players. And we don't need to set this to run on the server because this is already being run on the server over here. And for this time, we need to set this to 0.1 seconds and looping every 0.1 seconds. And we'll do max once per frame. We also want to take this return value, promote that to a variable so we can save a reference to the check player timer. That will be able to stop this timer once the red light is over. So every 0.1 seconds, we're calling this event. What we need to do is right click and get the game state. The game state class holds a reference to all the players on the server. So off of there, we can get the player array. This is the player state array. This has a reference to every player connected. This is automatically set up in every multiplayer game. Then you can do a for each loop. So for each of these players connected, we want to get the pawn. Player state get the pawn. So we're getting the pawn object reference from the player state, and from there we can cast to the third person character. Or if you set up an interface, you can set up, an interface blueprint to get a reference to that. But we're just going to use casting for the sake of this tutorial. Then from there we can get the velocity of the character, and we can check and see if the player is moving. So you can get the vector length of that velocity, and we can check and see if that is greater than 10 units to see if the player is moving the slightest. Okay, so we can do a branch, and basically this will check and see if the player is moving at all, and if so, we'll call a death event inside of the character. So compile and save that. You want to head over to the third person character blueprint. If you don't know where that's at, it's basically in the third person blueprints and third person character. But in here, we're going to add a simple death event. So just underneath your jumping and right click, add a custom event and name this to death event. Set this to a run on server. And right now we'll just leave it like that. We'll go back to our BP doll, and off of the true, we can take the reference to our character and call the death event. And we can hook that up for the true. So now that is basically our loop. Now after this timer, it gets called, we want to do a little bit of a delay because we want to, after the red light, go back to green light. So off of this check player timer, we're going to do a delay. And we'll do a random delay. So we'll do a random float in range. So with the range, we can set this to 1 second will be the minimum, and the maximum value will be 3.5 seconds. So anywhere within this range will be randomized. And then after that, we'll go ahead and we need to stop this timer because we need to stop this from firing off. That way the players can move without being killed. So we're going to get the timer and clear and validate that timer. Basically, that will stop this timer from firing off. And then we can go back to green light. So we can call this event all the way back over here to start the green light, reset this Boolean value, turn the doll around, and the players can move freely. So we'll call the start green light. Now if this is false, meaning if this is a green light, we want to basically do delay and then go back to red light. So we want to copy our delay, paste it down here, and for the false, plug that in. And we'll delay for the same amount of time and then call the start red light. Okay. So basically what happens when it's green light, we'll turn the doll around so it's not facing the players. Then we call this Boolean branch, we wait for a couple seconds, and then we call the start red light where the doll turns around, and we check and see if there's any players moving. If so, we'll eliminate them. And then after a couple of seconds, we'll go back to green light. So this is the basic game loop. So now we need to set up this death event inside of the character. So go to that in the third person character blueprint. So we need to go ahead and add a variable, call this safe ? And get this Boolean variable and do a branch. Because we want players to be marked safe as long as they are in the finish line. Okay, if this player is not safe, we'll call our death event. So we need to right click and add another custom event and call this our multicast death. So we need this to be set to multicast, that way it will happen on all the clients. And for the false, we can call the multicast death event down here. And basically what we're going to do is stop the character movement and have our character ragdoll. And maybe we'll also play a little particle effect. So we'll get a character movement component, and from there we can stop the movement. So stop movement immediately. We can also, off of here, disable movement. That way the player cannot move anymore. And then we can also simulate physics. But in order to simulate physics, we need to change some of the settings on our character. So select your character mesh over here, the component, scroll down or search for collision. And under the collision settings, you want to change the collision presets from character mesh to ragdoll. So change that setting like that. And then we want to get the character mesh down here and set simulate physics. That way our character can ragdoll, and set that to true. Then for our little particle effect, what we'll do is we need to add some starter content or a little explosion particle effect. So you can either add one through Fab, the marketplace, or you can go over here and click on this add button, add a future or content pack, and head over to content and we can add the starter content and click add to project. That will go ahead and download that and add it to our project. Okay, so it's been added, so we can actually close out of there. And now we have a folder for starter content. You can see it comes with materials, particle effects, props. We have under the particles this P explosion. So in our third person character, we can spawn a emitter. We can call the spawn emitter at location. And the emitter we want to spawn is our P explosion. Okay, the one that we just added. Now for the location, we want to spawn it at our actor's location or this player's location. So you want to right click and get the actor location. So we can get their current location, and then we're going to just do a add operator and add on the Z value 50. So plug that in for the location. So that will just spawn it a little bit above the ground. That way it's, where the player is standing. And now I think we have everything that we need set up. So I think we should be able to test this out. So in order to test this out, you want to play this as 2 players, and the net mode has to be either listen server or client. Okay, you could test this out as standalone if you're playing in single player, but since this is a multiplayer tutorial, we'll be playing this as either listen server or client. And then I'm going to do play in new editor window. And also, a very important thing that we need to do is we need to replace this doll. So right now, this is just the static mesh. So we need to go ahead and delete this. Make sure that you go into your blueprints folder and drag in this BP doll. Okay, and then we need to rotate it so it's facing the player. Okay, so very important that we actually drag the blueprint in, otherwise this is not going to work. Okay, so make sure that you drag in the blueprint in the level, and we have this blueprint doll right there. And one thing that you may notice is If we actually play over here, we're not going to see the doll turn around. So if I just keep running around, see, I randomly die. Okay, and the doll's not even turning around. However, if I actually play from here, so if I click play from here, look what happens. So we can see him turn around. So that's because the doll at this distance is not relevant to the player, meaning that any updates, any replication updates will not be replicated to the player because he's this far away. And this happens with every actor in Unreal Engine. So either what you need to do to fix this is to increase in the doll settings. If you head over to class defaults, you either need to increase the net coal distance, which is basically like a invisible sphere on the doll. Increase that value, that way player will receive more updates further away. Or what we can do is, in this specific case, we can check the always relevant. And that will mean that we will always receive net updates, net replication updates from this blueprint actor, no matter where this is located in the level. Okay, so once we check that, now if we hit play, what you'll notice is if I'm at the very end, we can now see the doll rotate. Okay, one other thing that we need to fix is it's not the right direction. So let's go ahead and actually clear the rotation. So let's go to our BP doll and select this. And what I think we'll do is we'll actually set, instead of using the world rotation, we'll set the relative rotation. So delete that. We'll just do a set relative rotation. That way we'll only update the doll's relative rotation. That way we can face the player like this, okay? So that's what we'll do to fix that. So now you can see that the doll is now facing the player, so this means red light. And as soon as the doll moves away, we can go ahead and start running. Okay, if it faces us, that means red light, so you can see we got eliminated there. So we gotta stop. And we'll continue, start running, stop. Okay, if you see, if we move just the slightest bit, we get eliminated. So we can now see that that is working. And again, because we weren't seeing any updates, it's because of that net relevancy, which is controlled by this value right here. This is the sphere, the distance from the player to this actor that will receive updates, or you can hit this checkbox to always receive updates. So those are the two options. Okay, so that is our BP doll. The next thing that we need to add is the finish line, so that players will actually be marked safe if they cross the finish line all the way over here. And also we should take all the player starts and try and move this a little bit closer to the starting line. So to create our finish line, in our blueprints folder, I'm going to right click and create a new blueprint class of the type actor and name this BP_finish line. And double click, open this up. And this will just be a simple box collision. So add under the components, add a box collision. So search for box collision, select that. And then over here, we're going to head over to the event graph, delete all these events. We also want to make sure under the class defaults, very important that we check replicates. So under class defaults, check the replicates, because this will not work for multiplayer if you don't do that. Then select the box collision and scroll down. We want to add some event begin overlap, and we also want to add a event end overlap. So when the player overlaps with the box or when they stop overlapping with the box. So the first thing that we'll do is a switch has authority. So we just want to make sure that everything thus far runs on the server, not on the client. And we want to check and see if the actor overlapping has a tag. And the tag we want to check is called player. So we're just going to check and see if this is a player, and we'll do a branch. And also we're going to do the same exact thing on the end overlap. So copy and paste this down here. Hook up the execution for the other actor, we'll hook that up for the tag. Okay, now up here we want to get this other actor and cast to the third person character. Again, if you had an interface, you could call the interface, but in this case, we're just going to use the cast. And then from there, we can set the safe Boolean. So remember, we added this Boolean in the character called safe, and we can set that to true, because if they overlap into the box, if they cross to the finish line, they are marked safe. Okay, if they, for whatever reason, leave this box, we can set that to false. So copy and paste this down here, hook that up for the true. For this object, we need to hook this up for the other actor. And then we can set this to false, meaning they are no longer marked safe. So compile and save. The only thing that we need to do now is add this tag to the player blueprint. So copy this player tag, head over to the third person character, class defaults, and under the details we can search for tags. And under the actor we have tags, so we want to add a new tag over here and name that player. And you want to make sure that it follows the same capitalization, punctuation, spelling as what we used over here in this actor has tag. Okay, so just double check, make sure everything is right. Under the class defaults, make sure that's replicated. And now we can take our BP finish line and scale this up, drag it in the level, scale it up. And basically you want to scale this box to be the entire size of the finish line and make it this wide. Okay, pretty much like that. And we'll scale it up. So as long as the players cross the finish line and are in this volume, they're protected. So now let's go ahead and actually test this out. So it's starting, we can go ahead and start running. Stop moving. Okay, let's go ahead and keep running. Stop. You can see that the motions are completely random, so it can wait up to 1 second or 3.5 seconds. So let's go ahead and keep running. We're almost there. We just got eliminated. Okay, maybe we can make it with this player. Okay, we nearly about made it. And now that we crossed the finish line, you can see that we're protected. So I can jump around, move around, and we're not going to get eliminated. However, if you cross out of the finish line, look what happens. So if I walk over here, you can see that we're eliminated. Okay, so basically that is how our finish line works. And that's pretty much our simple Squid Game red light, green light. We added this blueprint doll that, detects if players are moving. It is fully replicated. It will rotate back and forth to signify red light or green light. Then if the players cross the finish line, they're marked safe. And you could also use this to determine, which players can move on to the next game. You could use that Boolean. That's pretty much it for this video. So I hope you guys enjoyed, and I'll see you guys in the next one.